Here we have gathered the data to investigate how the average temperature increases in spring and summertime affect the number of bark beetle outbreaks, the max number of dead trees in an outbreak, and the max bark beetle population size. Let's use the Google Sheets to analyze these data. Let's choose the number of bark beetle outbreaks and the temperature increase. We can insert a chart. Then we can select which chart we will use to visualize the pattern. We can use the scatter plot to do some preliminary analysis to see the trend. After some formatting, you can see when temperature increases in the summer, the number of bark beetle outbreaks also increases. If the trend here is not clear enough, we can also plot the mean. Now we can see the average number of bark beetle outbreaks increases when the average temperature increases in summer. In the same way, we can plot other two outcomes. We can see the max bark beetle population size and max number of dead trees also increase when the average temperature increases in summer. Why does this happen? Remember, each bark beetle produces two offsprings, but when temperature increases, some bark beetles are able to produce two more offspring beetles. The higher the temperature increases, the more beetles are able to do so. It's interesting to note that even just a small portion of bark beetles are able to produce just two more offspring, it already leads to more severe and frequent bark beetle outbreaks. In the same way, students can investigate the effect of the droughts and winter temperature increases. Many strategies have been used to mitigate bark beetle outbreaks. Let's test three strategies here. Let's first set the model to simulate the situation when the temperature has increased. We can see severe outbreaks occur over and over. Let's see what happens if we remove the lightly infested tree. In other words, once we find the tree is infested by a few beetles, we remove it immediately. It seems we still get these peaks, but if we look closely, we can see the number of dead trees is relatively low. It's below 11 dead trees, so it's not an outbreak. So we might have one or two very moderate outbreaks here. Then what will happen if we only remove the heavily infested tree? In other words, we wait until the tree is infested by many beetles, and then we cut it down. Now we can see we actually have multiple severe outbreaks. We can run multiple trials to test the results again and again, but in general, we will see that remove the lightly infested tree is a better strategy to mitigate bark beetle outbreaks. Now let's try the thinning strategy. Let's thin 4% of mature tree. In this case, we can see the bark beetle population fluctuate. When we check the dead tree number, actually we have outbreaks, but they're moderate. Let's try 80% thinning. We will still see the bark beetle population fluctuate. But if we look at the number of dead trees, we can see we only have two very minor outbreaks here. Now let's try 10% of thinning. Looking at the number of dead trees, we do not have any outbreaks. We can gather more data to test the thinning strategy. And we can see we need to thin the forest to a certain extent to generate a positive effect. Also, when we thin the forest, the max beetle population size decrease. Also, the max number of dead trees decrease. This model is part of the curriculum. We want to support students to learn science in three-dimensional way. Let's talk about how this model can support all three dimensions. The most obvious practices include use a model to describe and explain a phenomenon, and then gather data to construct explanation, and analyze interpreting data using mathematical thinking. While students are doing so, they also apply multiple cross-cutting concepts. They are investigate the stability and changes in a complex system where there are multiple inputs and outputs. They also look for patterns, identify causalities. They also examine the phenomena at a different space and time scale. A class of core ideas are embedded here. For example, bark beetles can reduce the number of host tree population. Both the beetles and the host tree, they rely on the environment. The growth of host tree and the bark beetle populations rely on their resources. And we can clearly see the dynamic changes in this forest ecosystem. And then we can see just 0.5 and 1 degree Celsius changes in the environment lead to big difference. Overall, using this model can engage students in three-dimensional learning and develop their understanding about bark beetle outbreaks and the relevant scientific ideas. When you do this activity, you may put students into small groups. You want to give students enough time to gather data, analyze data, and reason about data. You can also let each student gather one piece of data to save the class time. Give it a try in your classroom. Leave your comments if you have questions and any other thoughts. Thanks for watching.